Hey everybody, so this is kind of a meta tutorial or a discussion. There is going to be some practical Macs later on in this video, and I'm going to want you to build that with me, so there will be a hands-on aspect to it. But really what I want to do at the beginning here is just talk about some of the ideas that we've been exploring in a little bit more depth. And I've realized that one of the things that people keep saying is, what can Macs do? Or, oh, Macs can do anything. And I realize that there's a misattribution here, because Macs isn't a piece of software that does things in the way that Ableton Live is about editing and playing sounds, in the way that Adobe Premiere is about editing video, or Photoshop is for editing still images. So the question, when you're talking about a language, the question isn't really what can that language do, because Macs and all programming languages are just that. They're languages we use to communicate with the computer. We use to ask the computer to do something that it can do. And Macs on its own does nothing except requests that the computer play a video, play a sound, capture an incoming video, analyze that video to identify a point within it. And I think that might be part of the reason why it's such a hard question to answer, because what we can see here is on the Cycling 74 website, there's tons and tons of projects made in Macs, thousands of them, and they're not particularly about what Macs can do. They're examples of what artists were interested in having the computer do, and used Macs as a way to communicate that intent to the computer. So stepping back to that bigger question, what can the computer do? And when we're talking about using media in performance, the computer can do pretty much everything. We just need a language that's particularly good for getting the computer to do the kinds of things that we as artists who work in performance do. So that's what Macs is. It's a particularly good way of making requests of the computer. I would like to send sound to 8 different speakers. I would like to send video to 3 different projectors. And it's not Macs that is able to send sound to 8 different speakers. It's that particular computer has a sound card with 8 outlets. If it does have that sound card, Macs can talk to all of those 8 outlets. Not all software can. If there's a video card in the computer that can connect to 3 or 4 different projectors, it's the computer's ability to send images to multiple destinations that we're using Macs to leverage. So, Macs is, I guess, in answer to the question, what is Macs good at? Macs is good at the kind of things that we tend to be interested in doing as artists working in live performance. Another thing that people have said is, I want to push Macs to its limits. Well, again, what are the limits of a language? Computers have limits. Computers are hardware. They can only process so much data at a time. They can only handle so many channels of sound. They can only handle so many video projections. They can only handle so many simultaneous processes. You will hit the limits of the particular computer that you're on if you push it hard enough. You won't hit the limits of Macs, because Macs is simply making requests of that computer, of that hardware. They say that software is always faster than hardware, and I think it's also fair to say that software is always more capable. Good software is always more capable than hardware. You can try to do more in Macs than your computer is capable of supporting. So you're going to get low frame rates or audio dropouts. Those are the result of the fact of using Macs to push the computer beyond its capabilities. So I think the metaphor of a language is much better than the metaphor of a tool. And Macs does give us access to the things that tools also give us access to. The difference is that tools like MadMapper or Photoshop or Premiere or Isadora Isidore is kind of on the border. Isidore is closer to being a language than those others. They have an intent. They make assumptions about what you're going to do with them. And as artists, that's a limitation. It's also sometimes useful. If you just want to edit an image, don't build an image editor in Max and then edit your image. Do it in Photoshop. But if you want, for instance, an image to be manipulated in real time, in performance, where it's responding to some aspect of either your performance on stage or the audience or the weather or the lighting conditions or the temperature in the room, that's a Max project, because Photoshop is unaware of the temperature of the room, and there's no way to ask it to feel the temperature of the room. Whereas in Max, it's trivially easy to have it receive input from any sensor. We've looked at a handful of those that are available to us now. We've looked at the mouse and the keyboard and a simple application of audio analysis, a simple application of video tracking. The motto of Max used to be, and I liked it a lot, was connect anything. This notion that any things can be connected together in this software. It's a very good metaphor or a very good description of what Max is. It's a place where you connect real-world inputs to the functionality of the computer to pursue a particular performance goal. And so this is part of what distinguishes Max from being a tool, a piece of software that serves us towards a particular end. Max, and maybe this metaphor is too much of a stretch, but I would say that Max, like any good collaborator, is there to serve the piece, not to serve its own goals. You're really pushing at Premiere if you try to get it to do something other than edit video, because it exists to edit video. Max doesn't exist with an intent. It exists without intent, but it gives you access, relatively easy access, to a lot of the stuff that we typically like to do in live performance. There's many things that Max is not very good at. Max is not great at processing large databases of text. Max is not good at doing sophisticated AI. You can do some simple AI, some neural network stuff in Max, and a little bit of AI audio processing in Max. Max is not great if you wanted to create a web-based piece. Max is, it has the capability, but it's not a strong candidate for a web platform, particularly if you're working with imagery. With sound, there's an extension to Max called Rainbow that actually makes it quite powerful for web audio. But again, getting back to that idea of Max being a way to connect everything, Max itself may not be very good at AI, but it can certainly talk to other software that is. So, for instance, I'm sure many of you have played with Stable Diffusion, which is a well-known AI image generator, and Max can't really do that work and shouldn't do that work, but I happen to have Stable Diffusion running on this computer, and I can generate some noise, send it to Stable Diffusion, and it will generate an image for me. And here's the image prompts that I'm sending it. 3 people in a city, detailed thin lines. And Max didn't make this image. Max formatted the request, sent it to Stable Diffusion. Stable Diffusion generated the AI image based on the noise prompt that I'd given it. And Max grabbed this image back into itself, and then Max has the capability of taking this image and generating a new image from it, either from the same prompt or from a different prompt. And we can see here in a separate window, Stable Diffusion is doing its thing and gives us a new image when it's done. I may have clicked the button twice, so we might get 2 new images. As another example, here's Max communicating with an AI music generation tool called Magenta, which is a Google Labs project. And here I'm sending a request over the internet to generate a musical phrase based on a model where thousands and thousands of pieces of music were analyzed. And I can dump that into a music player here and hear what it sounds like. I can store that and recall it over in my right-hand player and make a new phrase. Can individually transpose these. And I can try some other saved ones I'd done earlier. So just a little musical note generator. And again, Max is playing back the notes. Max is making the request to Magenta AI. Max is conforming these melodies to a particular scale, biasing them, transposing them, setting the length of the loop that's going to be generated. But Max isn't doing the AI part of the work. It's just using this node.script. It's talking to a website and then making requests. And Magenta is a beautiful tool. This is just an extremely simple example of it. Just as one other example, here's Max. Max is not very good at synthesizing speech. And in fact, computers in general don't really have particularly good built-in speech synthesis, but Google has fantastic speech synthesis. So this is a Max patch that communicates with Google's speech synthesizer.
This is synthesized voice. TMY name is Amanda.
I misspelled it.
My name is Amanda.
So it's a really nuanced voice synthesizer that is not accessible as something to run on your own computer, but Max has no problem reaching out over the internet, connecting to Google's services, Google's API services, sending the text, and then receiving an audio file in return. And this is pretty advanced Max. So where are we at this point in the class? Well, at this point in the class, we're just learning the very basic requests that we might make in a live performance setting, with an emphasis on, as I've mentioned several times, an emphasis on not always getting the predictable response. There are tools that will play a sound predictably at the time we want a sound played, that will play a video at the time we want a video played, and those might be better choices than Max if we want something that's the same every time, something that's not responding in a nuanced way to the conditions of the performance, something that's not surprising the performer. Whereas Max is a great language for getting the computer to produce novel responses. So that's why we've looked at the random object, that's why we've looked at the earn object, and of course we're going to explore those things much more deeply. Again, these are extremely artificially simple examples being given just to give you an idea of how the language functions, how the grammar functions, how one would connect things to other things. So now we move into the practical part of the class, where I'm going to want you to build some things along with me. And I'm going to paste some things into the patch. You should be able to build these as well. So just pause the video and build things that are pasted into the patch, and then we'll continue together. Because the idea I want to highlight here is around this notion of language. You notice that languages don't have manuals. Software has manuals. Languages have dictionaries. They have thesauruses. They have books on grammar, books on style. But there's no manual to use a language, because a language is infinite in a way. A language is something that you manipulate towards your goals of communication or obfuscation of communication or poetry or instruction. So in that sense, although the exploration part, the discovery part in Max is difficult, it is the essential part. It is the work. The tutorials, the learning of the objects and how they function, that's the first step. That's the beginning place. And with that, you immediately have to start trying to use those objects and those structures, as I've said many times, in ways in which they were not demonstrated. If you learn, I go to the store, I went to the zoo, I did not go to the park, right? Immediately, you want to try recombining those things. I did not go to the store. And that's the same principle in Max. And you might make an error. You might say, I did went to the store. And that's a grammatical error, but it still makes sense. You've still communicated something. And Max is like that. I've discussed this with a couple of you, the concept of graceful degradation. In the old days, if you created an error when you were writing code for the computer would just stop and say syntax error. I don't know what to do because you have not instructed me properly. And as languages have developed over decades, the best languages have incorporated a principle called graceful degradation, which is if you commit an error, the software will do its best to interpret that as some valid command. And human language is like that as well. If we say, I did went to the store, you've still communicated the information. You've made a grammatical error, and if you're speaking with a generous person, they're going to correct you so that your language improves. But, you haven't failed in your ability to communicate, and you've tried. And by trying, you've increased your proficiency with the language, even through making an error. So this is why the essential part, the real work, is in discovering the ways in which objects can be used that they're not demonstrated. And I'll give you an example from something a student sent me, which I thought was great. It was just a live camera grab and using the principle of the jit.dimmap invert 1 0 or invert 0 1, the student very rightfully and correctly noted that a gate can send the video to one of these inverters or the other, causing it to flip upside down. And that works, and that's totally functional. Is it good grammar? Is it good form? Well, no, but again, you're beginners. This is a valid discovery. This is a beautiful discovery. The next step in this is to say, okay, this is an object that does things. One of the things it does is invert. Do we need two of these objects to do different inversions of the same image? Or could we somehow just tell this object to change the way it's inverting? For instance, could we send it the invert message? Because we see there's an invert attribute, and we know, or if you don't know, I'm telling you again that almost all attributes have an accompanying message that allows you to set the attribute with a message that matches it. So let's see if this works. And indeed it does. I'm now using a single jit.dimmap to invert my image. You say, okay, all right, well that's great, and I've got a couple more combinations here. I can do an invert 1 1 to flip on both the horizontal and the vertical. Perfect, that works. And I can do an invert 0 0 to get the image back to normal. And again, that works. So now I've got this interactive control. And you might say, all right, these are lists that begin with the word invert and have two integers afterwards. We have an object that makes lists. We might say I want to create a list that begins with the word invert and is followed by 2 integers. And we realize, aha, toggle is one of those objects that puts out a 1 or a 0. And pack with no C will send its content every time it receives information at any inlet. So this should allow me to get all 4 inversion combinations just with 2 toggles instead of 4 buttons. Okay, that's great. And then you might recognize, let's clean this up a little bit. You might recognize, aha, random is 0 based. So a random 2 gives me either a 1 or a 0 randomly, a coin toss. And that's perfect to plug right into a toggle. To generate a random inversion of the image every time the button is clicked. And indeed it does. And then we think back and say, how can I automate this process? Well, there was the metro object, which generates a periodic bang. So, for instance, if I want this to happen every quarter second, every 250 milliseconds, I can use a metronome here, turn it on, and now my image is flipping every quarter second. Maybe that's not quite fast enough. Let's do it every 1/10 of a second. Right. And so now we've kind of gotten something interesting here just by following a thread of ideas, a path of ideas, of objects that we already know. We already know what they do. Oh my gosh, that's kind of crazy. We already know what they do. We've just combined them in a way we haven't seen before. And again, I'm setting myself to the level of information and experience that you have, and I'm trying to model the thought process that you might go through in taking the objects that you know and applying them to play, experimentation, and eventually to practical things that you want to achieve. And this brings up another point, which is good. Right now, if you have something really specific that you want to achieve, you probably don't have the tools to do it. You might have close, but you probably don't actually have the tool set to realize a very specific vision right now. That's fine. You will have that tool set. Right now, discover things. Learn the grammar. Learn the implications of the objects, not just how to use them in the context they were shown. And do that learning by trying things, by making mistakes, not by trying to see what's the right way to do this, because there isn't a right way. I mean, if we go back to the original example of the student, what the student gave me worked. So in that sense, it's right. But there's a cleaner, more elegant way to do it. And when that elegant way is implemented, it suddenly starts opening up these other possibilities that lead us elsewhere. So let's take a look at another example. Let me just take all of this and encapsulate it. And note that the grab turns off when I encapsulate it, so I need to turn it back on. And notice I left the jit.gl.layer out just so I can stick and enable on it, so it's not here hanging out if I don't want to see it. And let's take a look at another example. And this is something that many of you have noticed. If you send 2 movies to the same jit.gl.layer, they are going to fight each other. They're both going to try to display on the same layer. And this is because every frame is reaching the layer, and the layer is doing its best to show us every frame, but it can't. There's too many frames coming in. So this is a discovery in itself. It gives us a neat way to create a flicker effect, but it's also an opportunity. We say, okay, can I control this? Do I know any objects that would allow me to choose the way in which we alternate between these two movies? And we do have one, which is G-gate. Now I can turn on and off the video from this movie to the layer, and I can have another G-gate here, and I can turn on and off the video from this layer, and if I connect a toggle to them, now I have a video switcher. And I also have a controllable flicker by hooking up, for instance, the Metro object. And now it's just going to cut back and forth between these two movies 10 times per second. And that in itself is kind of interesting. We're getting an interesting sort of third composition here with the way the two videos are interacting with each other. Say, okay, but that's not really a flicker. I want it to be less regular. And again, we can think back and say, we were using the random object to give us a % chance of something happening. Say less than 20. And this is going to be true or false, 1 or 0. So the same logic will apply, but now the flicker will be less predictable. We're seeing the right image 20% of the time, because when this value is less than 20, the toggle, it receives a 1, and it turns both of these switches to the right. And of course you might be saying, well, why isn't there an object that just has 2 inputs and 1 output instead of having to use 2 of these G-gates? Isn't there a better object for this? And that's a great question to ask. That's a question that this exploration would lead you to. Like, hey, John, there's one with 1 input and 2 outputs. Is there one with 2 inputs and 1 output? And indeed there is. That's the gswitch object. And that's sort of the best way to discover new objects, is by realizing there is an obvious object that you don't know yet. And in that case, our patch is quite simplified. Exact same functionality, except since we have a 2 input and 1 output switch now, we don't need 2 separate switches. I'm going to undo this and just keep both versions. I'll slide this one over here and disable this layer and create the improved version here to a new layer. And now they're both functioning, but this layer is disabled. And this is just so you can keep this in your patch as a reference. You don't need to delete it. But you can see why I do delete things often from the patches, because it just makes it impossible to read. Maybe disconnect it and set it off to the side and add a note to it. And my patches don't have a ton of comments in them. Your patches should be filled with comments and experiments, and maybe even a tutorial will not generate a single file. Maybe it'll generate 2, 3, 4 related files where you're trying different things, trying the objects to ensure that you understand them, to solidify your understanding of them. Oh, and by the way, I started this Metro with a bang, which is actually not the best way to start a Metro. One should start a Metro with a toggle, so that you have a way of turning it off. So let's take this one step further and say, again, a natural progression from this idea of cutting between two movies. What about cutting between three movies? I'm going to actually switch back to my other version here because this will actually make it a bit clearer. And this work you can keep and comment somewhere else in your patch. And let's add a third movie. What's our approach here? Well, we have a single layer. We'll turn that layer back on, and you can get this movie, or this movie. And for this, I've got an odd situation. I was using the right and the left outlets of the G-gate because I was alternating between the two. But now that I have three, why don't I switch to the more conventional usage of G-gate, which, as I've pointed out a lot of times, the right side, the one side, should be the on side. So now if I start these movies, whichever one of these gates is on is the movie I'm seeing. So I see the third movie, see the second movie, see the first movie. Now, how can I change these simultaneously? When this one's on, these two are off. And again, you think through the objects that you know. And of course, there's multiple solutions to this. If I send a 1 to this one, I want to send a 0 to this one and a 0 to this one. So I should be able to just put that in a message. 1, 0, 0. 1 to the first one, 0 to the second one, 0 to the third one. But how do I get those to where they're going? And that is the unpack object, which allows us to take a list and unpack its three elements. And you might arrive at a different solution. That's fine. There are multiple solutions to this problem. This would be one that flows from what we've covered in the tutorial. So when I send it 1, 0, 0, it unpacks that. This is a 1, this is a 0, this is a 0. And notice that as I hold the mouse over it, I can see what the last message that passed down this cord was. So presumably if I want to cut to movie 2, zero, 1, 0, movie 2 is visible, movies 1 and 3 are off, and 0, 0, 1. That cuts to my third movie. And if we wanted this to be randomized, random 3, because there are 3 choices, select 0, 1, or 2, because those are the 3 choices that will come out of a random 3. And when it sees a 0, it sends this message. When it sees a 1, it sends that message. When it sees a 2, it sends that message. And let's see if it works. Random cutting between 3 videos. And indeed it does. Every time I click, I get a new random choice of video. Maybe that solution isn't the solution that would come naturally based on your understanding of the objects. So let's just look at another solution that thinking about this problem might generate. Say, all right, if I want to play this movie, I want these two to stop. And we go back to these infinitely useful logic objects. So we send a 1 to this G-gate to open it. And then we ask, is that value less than 1? No, it's not. So the answer is 0, and 0 closes these 2 gates. And this is how computers really work deep down. They only deal with 1s and 0s. They only deal with true and false statements. They just deal with thousands and millions and billions of them. And here we're just dealing with 1. When this thing is true, these 2 things are false. And this structure could be duplicated so that when this is true, these 2 things are false. And when this is true, these two things are false. Now you can see why I didn't choose this particular way of going about it, because it's messy, but it's entirely functional. Video 2, video 3, video 1, video 2, video 3. It's a way of proceeding using the tools that you have. And are there even better ways? Are there other objects? Of course, but again, these are two ways that you can get to with just the objects that you know. So let's introduce a new object, because you might create this and say, John, this works, but it's a mess. Is there an object that does this better? And indeed, there is, the switch object. We can just say switch 3. You probably want to save this, move it over to the side, put a comment on it, encapsulate it, start a new patch, do something that allows you to retain that information. And get in the habit of not using a space in a patcher name, because anything after a space becomes an argument to that patcher, which doesn't matter right now, but it will matter later. And so my switch allows me to take 3 movies, and if we hold our mouse over the inlet, we see 0 turns switch off, non-zero selects input. Okay? Make a new layer here, and make a button for 1, a button for 2, and a button for 3. Start these movies up. And right now the gate is closed. If I open input 1 of the switch, I see movie 1. If I open input 2 of the switch, I see movie 2. If I open input 3 of the switch, I see movie 3. And if I close the switch, there's no new live video going to it. But you notice, of course, that it doesn't go to black. So one easy way to handle that would be, again, our logic objects. When the value coming in is greater than 0, enable the layer. When the value coming in is not greater than 0, for instance, 0 is not greater than 0, that will be false, and that will disable the layer. So that's one way to cut to black. Video 1, video 2, video 3, layer disabled. So this is the kind of exploration that you need to be doing, taking these objects, each of which has a very, very simple function, and combining them in ways that expand your capability within the language.